Okay, folks, the usual things. Folks, please tell me how you hear me when you hear me. Sounds like people are hearing me well, and okay. People are needing less. Yeah, great. Okay. I thought I'd do something a little more interactive, um, and perhaps a little less and a little more useful than just sort of dryly presenting some material. We have lots of ways I could do that, but folks need a but folks are needing help sort of figuring out how to make how to actually solve a Prolog problems. So what I thought I'd do is that I'd let you throw problems at me that I haven't seen before, or at least that aren't, you know, like class exercises, and you can get those from 99 Problems or wherever, but toss me a problem I haven't seen before, and Annie's going to be very daring and attempt to solve them live and talk through my thought process as I do. So I will wait, and there'll probably be a little longer than normal wait while people go and dig up a Prolog program. Prolog problem for me to work. And I will talk a little just to keep the channel going, but so tonight I'm going to let the audience challenge me with Prolog problems, and I'll try to solve them live so you all can listen in on my problem solving process. So somebody, how could you implement find all? That's an interesting question, and the truth is you can't. It's a non-logical predicate that mucks about with the choice points, and those have to be implemented in C. You could trivially implement it by using like bag of or something, but that set requires basically some C to implement. So they're a pretty fundamental part of Prolog. If you want, however, I would try and do it using using the non-backtracking set val, which would allow me to do it. I'd rather solve something that I can solve with material you guys have been introduced to. I see Werner typing. Okay. Let's start with Werner's problem. Seems like something that I can solve. And Charles, that's probably just a little too large for this, just the constraints of wanting to do several of these in an hour. So I'm going to start with Werner's problem. I would say there's a real tendency to think that if you're, by the way, I'm using Control Shift plus to do that, and there's Control minus. And there's a tendency when working problems to use one character variable names and not comment things. And let me tell you, that doesn't actually make it easier to solve them. Okay, good. I've got a bunch of problems here now. So let's get on with this one. Okay, well, the first part is, how am I going to represent my graph? And let's say that I have an arc from A to B, and an arc from B to C, and then let's put a loop in it, an arc from C back to A, an arc from C to D, and an arc from D to E. Okay, there's a little graph. So let's just start by traversing the graph. Sometimes if you're presented with a problem, you can break it down for I'm not certain. I won't mind not participating if it solved those big green circle overcrowded thingy, so I can take my son to bed. I'm not certain what is. yeah, I'm not quite understanding that, but okay. So, so we are going to want some predicate. Find root, start, end, and root. Okay, and fine. Well, tell you what, I'm not going to bother with pldoc, but I am going to at least document what they are. Now, this is going to be some kind of recursive call. Oh, we need practice problems for the lecture. No, I don't think that's got anything to do with the mouse's big green circle. Tuis is just suggesting that we do a thing that makes the most people happy from a mouse's big circle, the big green circle. Okay, so what are those called? Nodes. If we are at the end node, then the root is to do nothing. Okay? This is a pretty straightforward way of doing things. And if we are not at the end, then we're going to have to find some arc and prepend it to the rest of the solution. We can get away with prepending it because, of course, we're going to solve for this arc and then find the rest of the solution, which will be the later moves. So, all right. So here I have arc. I'm going to call those A and B. Come to think of it, they have to be the start. I've got a little problem here. The arc is, this is probably an undirected graph. So, undirected arc from A to B. If there is an arc from A to B, and undirected arc from A to B, if there is an arc from B to A. Okay, so now we want an undirected arc from the start point to some node X. Let's call it a midpoint. And then find root from the midpoint to the end. Yeah, let's make certain that we're not at the end, by the way. Midpoint, the end, and that will be the rest of the root. And then, okay, notice this is heavy. That's because it's a singleton. It's not referred to anyplace else. And that's because basically we've got, instead of arc, we probably just want start midpoint. Okay, I'm going to make a pair out of those by cabbaging off the minus operator. Anybody got questions about all this stuff? Fire away. All right. So, and I don't even have to run this. I know it won't work. Here's the reason it won't work. It'll go from A to B to B to C to C to A and then get in trouble because it's going to keep looping. Okay? So, when would I use a cut instead of a condition on the alternative rule? If I need to be steadfast, which is what you're asking for, that is that it truly is not going to give me that extra cut, that extra solution, then my it might be very difficult to get the inverse condition for the alternative rule, in which case a cut would be a better solution, using a cut on the first rule. Won't the first clause find root node get caught first? So we don't need the start equal, and it would, Corey, except that we might backtrack. And if we backtrack, we might fall into the second one. This is a little bit of defensive programming. Prolog's actually a little more defensive programming is not as much a code smell in Prolog as it is in other languages, because Prolog's background is very much natural language processing and AI, where you never knew what you were having thrown at you, and so just being defensive was actually a sane thing to do. Prolog's contracts are very weak, and Prolog really doesn't work with contracts in the same sense that many other languages do. So, okay. So we do have a problem here. We got cycles. How does start midpoint work? If I do, I think it's display. Display, display is a handy thing that doesn't expand operators, that prints out its argument but doesn't expand operators. So 1-2 is just a is just going to be the complex term with functor minus or dash and the arguments 1 and 2. So that's how that works. It's just a cheap, easy way. I could use any other operator. I could do this or this. Minus is kind of traditional. You'll also see slash used a lot. And in option lists, you'll see equal used a lot. It's pretty common pattern. For example, Sweet Prolog has an HTML library, and you will often see attributes on tags defined using this kind of list with the equal sign. And in fact, smart programmers sometimes just go ahead and allow any of them. Okay, so we got one problem, and that's this looping business. There's a couple of ways I can solve it. One way would be to keep a list of nodes I've visited. Okay? So, the the minus just doesn't have any meaning here. No, I'm just using it because it's an operator that's already defined. It doesn't have any special meaning other than it glues two things together. So the way I'm going to do this, I'm going to define find root, start, and root as being find root with an underscore. Some people will use an underscore to make this a different thing. Here's another way of doing it, is to just add an argument. It is just a structure. It's a complex, yeah, it's a complex term. Now, okay, in this third argument, I am going to put the list of nodes I'm already at. So the list of nodes I've already visited. Well, I've already visited the start. So let's just stick it on the list already. Okay, now I have to fix up these. And I don't really care where I've been at this point. But here, I always call this so far. But I don't think there's much start's already going to be on the list. So I am going to have midpoint and end, and then I have to add the midpoint to the so far. And okay, now I only got one problem with this, and that is I'm not actually testing to make certain that this is an acceptable midpoint. So let's make certain that it is not provable that midpoint is a member of so far. Okay? All right. Questions about this? Okay. Now let's try and find a root from A to E. Find root A to E. And there we go. On backtracking, we get other roots. Okay. I'm fairly confident in my solution, so unless somebody's got suggestions of things to let's go back and grab the next problem. Okay. Is it, let's see here, boom. Compute the list of all divisors for a number. Okay, for an integer. All right. Sure. Yeah, somebody's asking for a recap, so I'm going to give one. Okay. All right, what we have now, we have arc, which just defines the graph by saying that A and B are connected and so on. Okay. And then we have, yes, there are two find roots with different arities. and you will see this a lot in Prolog code, they are different predicates. Be careful. And it's not at all unusual for people to do exactly what I did. Okay, back to Tweet's question. Undirected arc, under arc, is simply one of two things. Either it's an arc. If we had arc AA, well, we need to ensure start is then equal to midpoint. Hang on, I'll answer that in a minute. I'm going to finish going through this. Find root, then, is available in as two predicates. And in fact, let me tell you, this is a critique of my own code. Put a blank line between your predicates. Now it's more obvious, right? Put a blank line between predicates, and that way, now it's obvious that find root is actually two different predicates, one of arity 3 and one of arity 4. You can even do something like this. Fancy word, familius, for find root 3. Okay? Boom. All right. So find root 3 just starts the problem off by making a list of, by passing in this list. Now, we take the trivial case first. We're at the solution. If we're at the solution, we don't need to add any more arcs, and we just, the answer is the empty list. If we're not, then this is going to bind. It's if we're not, then this won't bind because the two will be different, and so we will fall into. Excuse me. By the way, those of you who would like to keep in this business for a long time, I strongly recommend Workgrave. We will fall into the second case. The second case makes certain that we didn't backtrack into it by checking that start's not end. And then now then we get an undirected arc. We then so we're going to get one of these possible moves. We're then going to make certain that we aren't moving to a place we've already been. That removes our loops. And then the last thing we need is, well, that was a possible move. Can we find a root from the new position, which is now midpoint? Midpoint is now kind of where we are. So I will try to find that. Is there a solution from midpoint to end? And don't go through midpoint again. If I do, so I don't want to go through midpoint again, and I don't want to go through anything else I've been through, so I add midpoint to the front of so far and make the recursive call. That's going to solve for the rest of the problem, and we have a typical recursive solution. Okay. Niall's question. If we had arc AA, we need to ensure that start is not midpoint. Yeah, actually, if you have an arc AA, that can never be part of a solution for graph traversal. You might want to include those, but one way of getting rid of them would be to ensure that in undir arc that the start and the end are not the same. That would just exclude those arcs. Now, it might be that you're, for example, generating something. Does it have a very bad consequence for the time complexity that we do the member check using a list? It is order n at each stage. Yes. There are a couple of ways we could get away from that. One way would be to do an assert. We can do a retractile, but there's a couple of problems with the assert solution. The first of which is that it is hell for anybody using this in a multi-threaded environment. Second problem with using an assert is simply that it's slow. Doing an assert is quite a slow operation. So I would probably go ahead and just use member. Member's quite quick. It's implemented in C and is it kind of depends on how big this graph is. This clearly is not how casually I would do this for some absolutely ginormous problem that got run thousands of times a second. But no, I mean it's not bad. So there is one other way we could do it, and that's something called iterative deepening. And that is, instead of passing in the list of nodes I've visited, I'll just keep a count of how deep I am in the stack, and I'll basically decrement that count. I'll start it at some constant, I'll decrement it, and when I get too far, I give up. Is code with cuts harder to use concurrently? No, not particularly. What is harder is that it is harder to automatically make concurrent code with cuts or other non-logical things. Basically, yes, you get lists in Prolog. You could do a tree pretty easily. Doing a hash, the problem is that you only have a single-ended structure to index into the hash table. If I was doing this on a large project where I had thousands of arcs, I would use library record, which provides you access to a C-style table record, and that would be a solution for this. So I would do that, or I would use a B tree. Implementing trees are pretty easy in Prolog. They're just nested complex terms. So that would be another way. But yes, all the time is taken, is probably taken here. Okay. All right. Another way to do it that would be performant but ugly would be to store the list of things I have done as an integer. For example, if I know they're single characters, I know there can't be more than 26 of them. So if I use base, so if I take 26 bits, I can just flip them, and then I can do a bit operation and find out if it's there. But yeah, I think most people just use member unless it truly was big. Okay? All right. Where are we on to? Bit sets for the win. Yeah. For what it's worth, I know that there's at least one image processing library out there for Prolog that just represents the image as an integer. Okay, and sorry, I'm going to have to go find the second question. The predicate divisors, to compute the list of all divisors for a given natural number. Okay, let's do that one. And okay, and I'm going to all right, and I'm going to ask you guys for advice. How should we proceed on this? Let's kind of solve this one a little bit together. And so I'm going to weigh out the oh great, I'm glad the recap was useful. Okay. All right, have an extra predicate that has the current divisor candidate. Okay. So basically we're going to do find all, divisor, let's find one divisor at a time. Is this what we're suggesting here? And then we'll find them all by backtracking. D.V. Burkle, I think that's your... and what do you have to do to be a divisor? And we probably need Ann. Okay. All right. Anybody know what generate and test is? How could we return the divisors on backtracking? I can increase the font size a bit. Hopefully that's a little bit helpful. Yeah, 0 is n mod divisor. That works. Okay. So we're back to Mouse's big green circle. How did Mouse get circles? How did Mouse get circles? Yeah, proof by construction. Yes. Hippo is a generator of circles. What would be a generator of candidates then? Something provides circles, right? Hippo provided circles. What would provide? Yep. Jens has it here. Something provides circles, then test the circles if they're the right kind. Great. What would provide candidates? And here, since I'm kind of working these, I would immediately think of between, which is a library predicate that returns the numbers from its lower bound to its upper bound on backtracking. That would provide us numbers, and every divisor must be in that set. And in fact, all the divisors are smaller than n, so at the very least, if we pick 1 and n, and we pick a divisor, and then we use D.V. Burkle method. 0 is n mod divisor. Okay, let's compile that and find the divisors of 8. 1, 2, 4, and 8. Let's try it with something prime. Okay. So Mouse's big green circle. Generate step, test step. All right. Okay. And this is straightforward solution. Yeah, you know, the funny part is that I was kind of like, oh my God, I don't see the obvious solution for that one. Yeah, so, okay. Pseudo poo without using constraint logic programming. That's probably just too involved a problem for the 15 minutes we got left. So, cool. All right. Somebody got another problem for me? I think we got the Sudoku one, but I don't want to do that. That's just too involved. And create a logic table for a Boolean expression. Okay. Let's do that one. I don't think there's a simplified version. Let's do the Boolean expression. Re-implement permutation. That's a good one, but I'm going to use this other one about Boolean expressions because, that might actually be kind of a thing to do. Would people rather see me work the problem with Boolean expressions, or would people rather have me kind of do a quick 10,000-foot flyover of something I worked on? Okay, I'm seeing a vote for that. So I'm going to do that. That's a cool thing to do. We've only got 11 minutes. I will tell you that I'm going to run over. Anybody who wants to, feel free to. Okay, we're going to, all right. This is available at Annie Poo. Anybody who wants to follow along. I'm going to pull up a open source project I've worked on. Yeah, the EU and US sessions really will be different. Okay. And then let me remember where this thing is. Okay, so yeah, so you can clone that repo, or all right. So what this is a user identity and user management package for Sui Prolog that I've been poking at. It basically does all of those horrible, boring tasks of getting users registered and sending them the activation email and all of that. The current status of the project is that it all runs. It's there. However, it's supposed to have plug-in modules for different login types. Oh, the font's from 10 foot. Okay. I'm sorry, folks. I will. Okay, and obviously I'm not going to go over all this code because this is like months of work for me. But, okay, but this is a pretty typical program. Like I say, what this thing does is you do a bunch of configuration, and then you have a website that you can sign up, you can register for. It'll send you the activation email and do all of that stuff, and then you can log on and log off. It handles the little remember me checkbox and so on. So, okay, I'm going to pull this out wider because we're not going to use the terminal anymore. This is a module. We'll cover those right at the end. They're not very complicated. And then this is imports of other modules. In this case, Prolog uses an abstract path syntax. So I can just say wherever you get your libraries from, and this is kind of expected to be the system libraries. And in this case, there's a package called HTTP that I suck in a bunch of stuff from. I then tell it that to add into the libraries what's going to become pack identity. So this line does that. And this is a module predicate. We're then going to suck in a bunch of stuff from pack identity into this. The file I'm actually reading is the test module. So this thing just basically stands up a small version of pack identity and then allows Selenium to exercise it. So, okay. Boom. All right. You start it all off by calling go. And go sucks in some settings. There's a built-in settings library. Checks to make certain that we're on a sane version of Prolog. Calls use default DB, which sets you up with a simple library persistency-based database to back the thing up with, and starts the server. And if it falls down, it kind of blindly assumes that it's because you weren't on a high enough version of Sweet Prolog, so it gives you a warning for that. These next two lines are directives, and in these cases, these are directives that that set up HTTP handlers. So you'll notice here we call HTTP handler. This is just the root path, that's slash, and then this is the root handler, which I only give the functor because it's going to tack one argument onto this at the time it calls it, and that argument is going to be a list with a whole bunch of complex terms in it that are different parts of the request. So I'll be able to find out what host I connected to me and what my search parameters were and all of that sort of thing. And then this last argument is an option from an options list. So this is in this case, I'm setting the option that I'm giving this thing a name so I can refer to it later. And then this package that I'm writing actually then allows me to add this option called role that demands that you have role user, which is basically you're logged in order to access the secret handler. This is a good example of a DSL use in Prolog. You can write out HTML in this kind of odd form. This is actually an A link tag, and it sets some attributes, and then has the contents linked to secret. And the attribute, of course, is the href, and then I can pass it location by a ID, and it's going to figure out where ID secret is, and then figure out what path gets to it, and then expand it out to that path. That probably went over quick, but there's some really good kind of Prolog tricks in that. One of these is href. Notice that this whole thing is actually just a compound term, but it's kind of a DSL of its own. And then even within this href tag, I could just put a path in there, but I chose instead to do this location by ID, and it sees that, oh, that's a location by ID. There's one more clause and whatever handles this, and it handles it. Okay, and then here's the secret handler that actually does some loads something trivial by JSON, just to make certain that I'm not leaving JSON as a, not leaving AJAX requests as a security hole. And this, again, takes a bunch more of this termerized HTML. This, by the way, is a, sorry, I'll have to blow that up. Whoop. I don't know what happened there. Oh, okay. Finally it comes in. Okay. This, with a backslash, as current user, that just expands to the text that it is the name of the current user. And that's implemented with a DCG term. So let me I'm going to hit Control-C, Control-N, and I get this little Prolog navigator. I don't honestly know if I can change the font size. I apologize, I cannot change the font size of this, but you can try it on your own. It's going to give you a something very much like the project window in an IDE, and we're in test. I'm going to go up, and then I'm going to go down into Prolog. This is a common organization of Prolog projects, is to have a directory called Prolog under them, and that's partially because the pack system expects it. And then in my case, under that I have identity, which contains all of the pack identity stuff. And this is all of the actual code. So, for example, login static. This actually just sets up handlers so that it will serve static files. So I can serve JavaScript and CSS. Obviously, such a package needs that, and they need to be in a certain place, so that sets it up. But otherwise, customize. Customize has what's called a multi-file predicate. Here is a hang on. Here is a multi-file predicate. Is the knowledge base shared between threads? It is, yes. The knowledge base is common to all threads. You can set up a meta predicate and mark something dynamic and thread local. And then it's only known by one thread. Okay. So this is directive that provides metadata about a predicate, and it says there is a predicate called local hook in customize, and you are allowed to define new clauses to that predicate anywhere in the program. This is a pretty common way of making kind of a hook. And then all over in the code, whenever I am about to print a string, I pass the string through this little predicate below. I suspect I'm not big enough yet. This little predicate local, which first checks to see if there is some customized localization of it, and if not, then gives you back what you passed. So this provides a really flexible way of doing your localization. You could have your localization in some table that is in a format that's convenient for communicating with your translators, or it could just be like some predicates, or and you might want to, for example, if you know you're always going to override it, you could start passing things in semantically. So, okay, and then there are some settings. These are just Prolog settings. That's what's in customized. I'm just going to kind of keep going till I lose my audience at this point. Let's see. Okay, as a Prolog expert, does Prolog, so to end what I was saying, feel free to drop off whenever you want. I have the funny feeling I have the sense that folks are like into this, and so I'm going to keep going for a bit. As a Prolog expert, does Prolog feel like a good choice for just about any of your projects, or when do you pick something else? I would have expected most of the infrastructure being some more common language and then most of the business logic being Prolog. Yeah, there's a business reason to do what you say, Tweez. The business reason is simply that it's far simpler to hire Node programmers than it is Prolog programmers. On the other hand, let me tell you, if you actually do be a all Prolog shop, then you end up hiring Prolog programmers, and most of the Prolog programmers I know are really good. So that's any of you starting companies, consider a niche language for just that reason. So as a Prolog expert, does I would expect most of the infrastructure. Yeah. So quite often that's done. There's a good way to do that and a bad way to do that. The good way to do that quite often is to make your Prolog server talk REST, and then make it, and then have it expose its endpoints as REST endpoints if you don't want to do your middleware in Prolog. Another choice, the kind of bad choice for most applications, is to fight all of the FFI stuff. The FFI stuff works perfectly fine, and if you truly are doing some mixed language machine learning thing with a bunch of Python and TensorFlow and a bunch of Prolog, that's the thing to do because speed is everything. But for the average web service, I would say do the JSON thing. Hang on, I had back in test, I have an AJAX handler. That's all in the world I had to write to make this little test JSON handler, AJAX handler. Make a handler declaration, and then in the handler declaration I say reply JSON dict, and I pass it a dict, and it converts the dict to JSON on the way out. I rarely, I certainly don't think, oh, I'm going to write some website, I should do it in something other than Prolog. I usually do things in pure Prolog. I'll tell you, that's partially because I often find myself working on little one-person projects. And those one-person projects, sysadmin can kill you. Dealing with Kubernetes and Docker and this and that and for some languages, that's brutal, and Prolog has a lot less of that. So I just stay with Prolog, and as long as I have a Prolog install, I pretty much do everything in that. Tried to start a little startup, and we had one script in Bash, and it basically installed Prolog, and then called some Prolog, and that Prolog set the rest of the system up. So we even things you might do in Bash. Okay, DV Burkle, if we have a big green mouse exercise afterwards, I will cut this off then. All right. Sorry, guys. Nobody warned me about the big green circle. But in that case, I think it's been good, and I'm going to see you all back on Slack. Okay, thanks. Last comment will be that we will see a lot more of this kind of real-world stuff as we move into the advanced course. The basics course pretty much is to get you to where you know Prolog and can comfortably program in the basics of Prolog so that we can move on to more real-world stuff. But we're pretty much done with much of the theory for this course. I'm going to put out I've just put out the DCG thing and then I've got a little section on practical stuff, and we're done. Right? Is that it? No, okay. Yeah, the stuff that isn't most good books. Tease, I hope you're signed up for the advanced class. There's a lot more of this in that. I'll see ya.